Nuclear structure. As discussed in the quantum physics unit, the atomic nucleus is composed of protons and neutrons. These are collectively called nucleons. Originally, protons and neutrons were thought to be fundamental, that is, indivisible particles, but were later found to be comprised of 3 quarks each. It turns out that there are 6 types of quarks, all with different properties. The proton is made up of 2 up quarks and 1 down quark, whereas the neutron is made up of only 1 up quark but 2 down quarks. This explains why neutron and proton masses are slightly different and why the proton has a positive charge while the neutron is neutral. Below is a table that shows the charge and mass on both particles. Nuclear nomenclature. How do we identify a nucleus? How do we differentiate it from other nuclei? And what do we call a particular nucleus? Nuclei are identified by a symbol and 2 numbers, just as shown below. Here, X is the chemical symbol for the element. It has 1 or 2 letters. Z is the atomic number, and it specifies the charge, or the number of protons. A is the atomic mass number, and it specifies the number of nucleons, that is, the total number of protons and neutrons. There's also a neutron number, N, which is given by A minus Z, but it's not part of our nomenclature. When we want to say the name of a nucleus, we use the element's name followed by its mass number. For example, uranium-238. Here's a periodic chart that shows atomic and mass numbers. Let's focus on one of the elements and see how the periodic table displays this information. I'm going to zoom in to about 200% and focus on one of the elements. Here I'm going to focus on manganese. You can see that the chemical symbol is Mn. The atomic number, that is the number of protons, 25. And if we look at 55 up here, that is the mass number,